Hello students, welcome in our new chapter number 10, vector algebra. Students, today I going ahead, our same as our chapter number 10. In vector algebra, it means it is a 3D. There are 3 dimensions. So first I introduced our octant form. It means there is the 8 directions in our vector forming. So you consider that's your one of the z axis, here x axis, and that is the y axis, and here your center origin 0 0 0. I will check I on the positive direction of x axis 1 0 0, one of the unit vector. Same j on y axis 0 1 0, same k on the 0 0 1. Yes, it is an octant form. It means there is the 8 directions. Don't worry, I show one by one. This is your 1x, y and z, 3 direction done. Now opposite sides of x, it is x dash, which is minus I, minus 1 0 0. One more opposite sides of y axis, this sides, it is a minus y dash, I mean y dash only. It is a minus j, 0 minus 1 0. And that opposite of z, z dash minus k, 0 0 minus 1. There are the total 3 and 3, 6 direction done. Now I go to one more 2. Students, this is are the next 7 directions. Is exactly this sides. Yes, and one of the opposite to back side. There is total 8 directions. Now I just show about first vector x bar, x1, x2, x3 belongs to r cube. This r cube, it means r cross r. Yes, it is called your 3D. Yes, in the 3 dimension. And having this 0 bar is your 0 0 0 is a vector having no direction. Yes, this is only one vector which have no direction. Yes, it is directionless, only magnitude available. Now x bar I just written is that x1i, x2j and x3k. Also I just derived the further solutions for the simplifications. Here 1 0 0, 0 1 0 and 0 0 1. So in any vector algebra you will check multiply inside that first data, second and third. So x1 comma 0 0, 0 x2 0 and 0 0 x3. Now if you added all that, you will get again your question check. That's all our internal parts is your scalar part. Yes students, here your x1, x2, x3, that's are the 3 values. The x1, x2, x3 is your scalar part. Yes, here x1, x2, x3 are scalar part of x bar. And vector part then ijk attach. So I just write down x1i, x2j, x3k are vector part of x bar, and that's your basic introduction for your octant form. Now I go to second parts, magnitude. Students, magnitude means a distance from origin. Yes, you correct listen. What is magnitude? Distance from origin of any vectors is called your simple magnitude, which have to under root x1 square, x2 square, x3 square, and they always greater than or equal to 0. Now take you magnitude for the 0 vectors here. Magnitude of O, yes, possible, having magnitude available, but it is directionless. Yes. Now next point, unit vector. Unit vector means a vector having magnitude 1 is called our unit vector. Yes, students, correct thinking you. Yes, a vector having magnitude 1. And unit vector, there are two types of unit vector. One of the in same direction and one of the in the opposite directions. So in same direction you will take plus having magnitude not equal to 0. Mention in the same direction. Similarly here students, x cap we will write down minus, but in the opposite directions. These are same directions. Sometime asking in exam, opposite direction unit vector, then minus. So here you write down in the opposite direction. And that's your students, your x bar done. Now I go to next point, direction cosine. Very interesting chapter, and students, very easy chapter. Only just point is properly understood. Next, direction cosine and direction angles. Students, there are the three direction angles: alpha, beta and gamma. Listen here, that's your octane form. Just properly I draw again, drawing x, y and z. Consider one of the vector here in the place of that, and I will show that here that is vector p making an angle with the x-axis alpha, second beta with y and gamma with z. There are the three direction angles and direction cosines, which is nothing, cos alpha, cos beta, cos gamma, and that value I create from this unit vector. You know the unit vector, x bar by modulus x bar, x1, x2, x3 by x1 square, x2 square, x3 square. You will take individually, all three are divisions students. Here first x1 by comma, x2 by comma, x3 by, and here write down x1 square, x2 square, x3 square. Similarly x1 square, x2 square, x3 square, same as x1 square, x2 square, x3. These three values are students your direction cosine, cos alpha, cos beta and cos gamma. Yes, and that alpha, beta, gamma is respectively making the angle with the x-axis, y-axis and z-axis. So there are the 2 points. Now I am making to alpha, beta, gamma also. That's your simple direction angles from here coming. So continue. Therefore, direction angles. We have to alpha first create. From that first value, cos inverse x1 by under root x1 square, x2 square, x3 square. Same beta is a cos inverse x2 by x1 square, x2 square, x3 square, and gamma is a cos inverse x3 by x1 square, x2 square, x3 square. These are the three indication of direction angles. Now one more point you noted students, always cos square alpha plus cos square beta plus cos square gamma is always 1, because if you are taking a square to individually, definitely your data is cos square alpha, cos square beta, cos square gamma. You will attach and make the square. So it is x1 square plus x2 square plus x3 square by x1 square, x2 square, x3 square. It is 1. And second also you point noted, always sin square alpha, sin square beta, sin square gamma is equal to 2, because I explained that sin square alpha, sin square beta, sin square gamma, which is 1 minus cos square alpha, 1 minus cos square beta and 1 minus cos square gamma. Check that. 1 1 and 1, total 3. And another you will take in one bracket, cos square alpha, cos square beta, cos square gamma, and that I know that 1. So here your definition, students, easily and simple way we can going them. Now students, I continue our example 1. Yes, example 1 is related our these questions continue and same as now all points one by one I explain to exercise 10.1 also students. So now students, I going first example 1 and then after example 2. Example 1 is that only draw the figure of the given vector making 30 degree with southwest at a distance 40 kilometers. So using your pencil scale and you will draw simple your coordinate plane y and x axis. Here I will take origin and students here taking your east, here west, that north, and here south. I draw south, this west, it means this here this sides you will taking that, and my degree is that southwest are taking that how many degree 30 and 40 kilometer. So here 0 to A 10 kilometer, A to B 10, B to C 10, and here D, and you write down scale 1 centimeter O to A, it is 10 kilometer. So here your answer O to D is what 40 kilometer, and direction of OD is making angle 30 degree with what south west. And here students, simple your first presentation for the drawing of that vector is done. Now question 2, identify vector or scalar. When vector only a statement have given magnitude available and magnitude and direction both available, then it is called our vector. Just like a vector defined first 3 Newton, it is a vector. And also that towards north, this is also students vector, and other all are scalar because they have only magnitude. Check 5 seconds no direction, 1000 semi no direction, 30 kilometer per hour no directions, 10 gram centimeter no directions. So it is your scalar. Here also scalar, and you can write down reason here only magnitude available. Same as here, similarly only magnitude available. And here students vector, here both direction and magnitude available. Here also students same as both direction and magnitude available. That's why I will take that is your vector, and that are students only magnitude available. And that also same is upper to same. So that students our example 2 is simple here done. Now continue students, question number 3rd example. In a given figure just identify collinear vectors, equal vectors or co-initial. And this is drawing given. What is a collinear? A vector having same directions, either opposite directions. Yes, that's your collinear. So first I identify a vector having same or both kind of same or opposite direction is called collinear vectors. Now you read in your questions, what is the collinear? A and C same direction, but B, C and D opposite. So my answer is here A, C and D are collinear vectors. Yes, because A and C have same direction and C and D have opposite directions. Now continue second. Read that equal vectors. When vector equals, magnitude and direction are same. Yes, if magnitude and direction are same, then vector are equal. Now you check which vectors is equal. These are, yes, A and C are equal vectors because here given one scale, one unit, this one unit and this also one unit given. Yes. And third, asking that co-initial. Yes, co-initial means at the same points they start that journey. So co-initial vectors are, here check, C, D. Also that this side B going. It means my answer is co-initial vector are C, D and B. Co-initial vectors simple given in the same initial points. Same initial points. Now students, I will start our exercise first. 10.1. Draw the sketch of the given vectors having making 30 degree. Yes, making 30 degree with given that, yes, east to north. Yes, east to north at 40 kilometer distance available. Yes, north to east, either east to north. What are you reading? Here written, and that's your diagram, y-axis and here x-axis. I will take just here east, west, north, south. So just north to east, either east to north. This side we will going that our scale that 1 centimeter, that 1, 2, 3 and 4. Here O, A, B, C, D. Each have 10 kilometer. Then total 40. And now east to north. Yes students, here that degree is taking that our 30 degree. And my answer is simple. Here write down one scale. Our one unit O to A, it is 10 kilometer. 10 kilometer, 10, 10 and 10. And making that OD is a 40 kilometer. And direction OD is making angle 30 degree with, yes, north to east. That student, simple. Your first answer is done. Now I going to second one. Is simple, identify it is your scalar or vector. Now students, continue question number second and third. Only just classify the following: scalar or vector quantities. Again I repeat, scalar means they have only magnitude available, no direction, and vector is magnitude available with directions. So first question, 10 kg, definitely they only magnitude. So here I will write down, it is scalar, only magnitude available. Next, 2 meter north to west. Yes, here students it is vector because both available, both our magnitude and direction available. Yes, next 40 degree. Yes, it is students what? Scalar. No directions, either write down only magnitude available. Now similarly students, you can check your next 40 watt. It is again scalar, only magnitude available. Now students, 10 raised to minus 19 coulomb. Yes, that is also scalar. Reason same, only magnitude available. 20 meter per second. Yes, it is direction given. In second sides that it is a vector. Here both magnitude and direction available. That's why I will write down the second and the sixth are in the vector forming, other are scalar forming. Now same as read that next question. Classify scalar and vector. Time period, definitely it is scalar. It is scalar. Next, distance, it is scalar. Only what? Only magnitude available. Force and velocity both are vector, because here force taking, it means how many magnitude available, that, and direction also available, in which side you apply your force. Velocity same. So it both are the vector and work done. Yes, it is scalar. And that, student, simple. Our question third also done. Now question number 4. Given drawing available that in this way, the direction A, in this direction C, and in this sides of our B vector, and in this sides of vector D, and asking that three questions. I just check my questions again. There is one of the A, C, B and D. Yes, now first question is a co-initial. Now second was that similarly equal, and third I have, yes, it is a collinear but not same. Collinear but not same. Very easy. One by one I just define my answer. Co-initial means starting point is same, then you can take co-initial. Check here, students, these are the co-initial. A direction, D directions. So I write down here A and D both are co-initial vectors. Yes, students, co-initial, I again repeat, having same starting points. Second, equal means direction and magnitude are same. What is direction and magnitude are same? D and B. Yes, D and B have same direction and same magnitude. So it is our equal vectors. That's your answers. And last I write down here, collinear but not same. Check A and C, opposite directions, it is collinear. Students, same direction and opposite direction, always it is a collinear. Yes. And distinct, for the distinct directions, different directions, it is a non-collinear. So here, students, A and C have our opposite direction. So I just taking it is collinear but not in the same. That's why I going that it is opposite. Yes, students, here your question number 4 is easily done. Now I am moving that 5th questions. Now, students, after ending 4th questions, we going 5th one. Answer the following in true false. There are the 4 different types of questions. First, A and minus A are collinear. Yes, definitely collinear, because they both have, check, only opposite directions. I just draw here one of the drawing for easy understanding. Consider here O is 0 vector, this side is A directions, this side is a minus A directions. Both are each are opposite, definitely it is collinear. And same initial, students, here same initial. So here write down, yes, it is collinear because A and minus A have opposite direction. Yes, students, you can write down the direction first and then after you will simplify that your answers. Now second, 2 collinear vectors are always equal in magnitude? No, check. A and C collinear but the magnitude is different. I just write down here answer is here false. You can write down here true. Students, here false. Consider here one vector I will take down, that A. Collinear vectors always in same magnitude? No, different magnitude. A taking 1, 2, 3. Different vector I taking collinear 2, 4, 6. Check, both magnitude are not same. Here magnitude of A, it is same as under root 1, 4, 9, root 14. But magnitude of B is you will take 2 common. 1, 2, 3. It is 2 root 14. No doubt it is collinear. I will taking double, but that not always in equal magnitude. Therefore, I will write down magnitude A is not equal to magnitude B. That's why my data is what? False. Now, third one. Third question, two vectors having same magnitude are collinear? No, this also false. Consider here one initial, this side going vector A, this side vector B. That is your A, here B. Check, vector having same magnitude. They are collinear? No, I not draw collinear because your A vector and B vector have same magnitude or not. 1, 2, 3. B also, two vectors having same magnitude. I just taking here minus 1, 2, 3. Check, magnitude of A. Already explained here root 14. Modulus of B, root 14. Yes, vector magnitude same, but they not collinear because this and this are both different directions. Yes, magnitude of A equal to magnitude of B, but A and B have different direction. Yes students, here I will that are easily different directions explaining that. Now fourth, two collinear vectors having the same magnitude or equal? No, they are not always same. Here also students you will write down false. Consider here our collinear vectors, one of the I draw in the octane form. You can easily understanding Z, X and Y. This is the origin. Check, two collinear vectors having the same magnitude or equal? No, two collinear vector I will take on X axis. Consider here 2, 0, 0. And here consider 0, minus 3, 0. Definitely they are collinear. But that having the same magnitude? No. This magnitude and that magnitude are different. First I will take A, 2, 0, 0. Definitely modulus A, 0, 4, 0. It is 2. Now B vector, 0, minus 3, 0. Magnitude of B. Students, it is definitely under root 1, 9, 0. Sorry, 0, 9, 0. It is 3. Check, magnitude are same? No, but they are collinear. It means our statement is definitely here students false. Now students, here our this exercise 10.1 is happily and simple done. Students, I further explanations for the new topic in the next part. Okay, bye bye.